name is Sushma, working as Assistant Professor in the Department of EC in Institute of Aeronautical Engineering College, Hyderabad. Today we are going to discuss about the problems on linear and circular convolution. So first problem is on the circular convolution method. Here in circular convolution method we are going to discuss the problems on graphical method, that is concentric circle method, as well as matrix method, and other problems are on linear convolution, which are graphical method, tabular method, and matrix method. So the first problem is here: find the circular convolution of x1 of n is 0, 1, 2, 3, the sequence, and x2 of n is 4, 5, 6, 7 using concentric circle method. Here, first condition we have to know about the circular convolution is to convolute two sequences in the circular convolution, the both sequences should be equal length. So the length of x1 of n and the length of x2 of n will be equal. Then only we can convolute these sequences in the circular convolution. As well as here the formula for circular convolution is y of m is equal sigma n is equal 0 to n minus 1, x1 of n and x2 of m minus n modulo n. So why? Because here the circular convolution is for periodic sequence. So this mod n indicates the number of samples in the sequence. After n samples, the sequence will be repeated. It is a periodic sequence. So here the both sequences are x1 of n and other sequence is x2 of n. Here we are going to get the formula is 0 n is equal 0 to n minus 1, x1 of n, x2 of m minus n modulo n, where m is equal 0, 1 to n minus 1. Here in x1 of n, in the problem they given 0, 1, 2, 3. So the number of samples in x1 of n is 4 and in x2 of n is the 4, 5, 6, 7. That is m. The number of samples are 4. So the length of the y of n, that is the number of outputs in the y of n, are maximum of L comma m, that is maximum of 4 comma 4, so 4. So the number of samples at the output we are going to get after circular convolution is 4. So here the index is starting from 0 for the both sequences. So the m value will be from 0, 1, 2, 3 because it has only 4 samples. So the m will be here 0, 1, 2, 3. So we have to substitute m is equal 0 and m is equal 1 and m is equal 2 and m is equal 3. We have to find out the y of 0, y of 1, y of 2, y of 3 in the concentric circle method. See here, if we substitute for m is equal here 0 in the formula, so we will get the y of 0, sigma n is equal 0 to 3, x1 of n, here x2 of m minus n modulo 4. So m is 0 here. So we will get here x2 of minus n modulo 4. N is 4. Number of samples are 4. So that's why here we are getting the modulo 4. So here we are multiplying the sequence x1 of n with the x2 of minus n and the products will be added. Then you will get the y of 0. Okay, this is the formula to get the y of 0. So here how to what is the procedure for concentric circle method means we have to represent both the sequences x1 of n, x2 of n in the circle. So how we have to represent means first take x1 of n series. This is x1 of 0 sample and x1 of 1 sample and x1 of second sample and x1 of third sample. So here we have to take one circle and we have to make equidistances. So here we have 4 samples. We have to make 4 points on the circle with the equidistance. Okay, we have to write the sample values in the anti-clockwise direction. So x1 of 0 and x1 of 1, x1 of 2 and x1 of 3. So here we are taking the x1 of n series samples, we are plotting on the circle in the anti-clockwise direction. Next, we have to multiply x1 of n with the x2 of minus n to get the y of 0. Sigma n is equal 0 to 3, x1 of n to x2 of minus n. So we plot the values of x1 of n. Next we have to know how to plot the values on the circle for the x2 of minus n. So for x2 of minus n, first we have to take the x2 of n. So for x2 of n also we have to, it is also have the 4 samples. So draw the circle and make the equidistance points for the 4 points. Okay. Make the sample values in the anti-clockwise direction. So the both indexes should start from the same point. So here x2 of 0 we are starting here. So x2 of 1 and x2 of 2 and x2 of 3, next x2 of 0. So this after x2 of 3 again it is a periodic signal. So again it is repeating the same loop. So here from x2 of n we have to get the x2 of minus 1. Here we are plotting the sample values in the anti-clockwise direction. Anti-clockwise direction. To get the x2 of minus n, we have to plot the sample values in the clockwise direction. Clockwise direction. Because x2 of minus n is equal to x2 of n minus n. So x2 of minus n we can write x2 of 3, x2 of minus 3 we can write x2 of 2, x2 of minus 3 we can write as x2 of 1. So here it is starting from x2 of 0 and clockwise direction. x2 of 1 value is 5, 6 and 7. So here we are taking the values in the clockwise direction with the same index point, starting point we should be the same. So here to find out the y of 0 value, we are multiplying with x1 of n with the x2 of minus n. That's why take two concentric circles, inner circle and outer circle, and make the equidistance plan. The outermost circle is for the x1 of n. The innermost circle is for x2 of minus n. So in the outermost circle already we know how to make the points is here in the anti-clockwise direction. So from here it is starting x1 of 0, x1 of 1 and x1 of 2 and x1 of 3. So it is x1 of n is for, we are plotting in the anti-clockwise direction. Anti-clockwise direction. For the inner circle, here we are multiplying with the x2 of minus n. So here x2 of minus n is here x2 of 0, x2 of 1, 4, 5. Here we have to plot the values in the clockwise direction. Clockwise direction. The both indexes should start the same point. So here x2 of 0, x1 of 0. Okay. Then we have to multiply the corresponding sample values, magnitudes. So 4 into 0. 4 into 0 we are getting 0 and 7 into 1 corresponding values we are getting 7 and 6 into 2. So we are getting 12 and 3 into 5 we are getting 15. So in the formula if we go for substitute n values, here it is the x1 of 0 for n is equal to 0, x1 of 0 into x2 of minus 0 modulo n, x1 of into x2 of minus 1 modulo n, x1 of 2 into x2 of minus 2 modulo n, x1 of 3 into x2 of minus 3 modulo n. The corresponding amplitudes will be multiplied here. So here for y of 0, x1 of 0 is 0 into 4 plus 1 into 7 plus 2 into 6 plus 3 into 5. So here we are getting 0 plus 7 plus 12 plus 15. Here we are going to get 34. So the y of 0 value is 34. So for y of 1, we should not change the x1 of an outer circle, because in the formula if we substitute m is equal 1, we are getting y of n is equal 0 to 3 x1 of n into x2 of 1 minus n modulo 4. So we are multiplying the sequence x1 of n with the x2 of 1 minus n. So here x2 of 1 minus n we have to multiply with the x1 of n. So how to plot the x2 of 1 minus 1 means we have to take first x2 of minus n, 4 points, 4 equidistance points. So this is x2 of 0, inner circle, for x2 of minus n, we should write minus n. That's why we are to write the values in the clockwise direction. So 0, this is x2 of 0, this is x2 of 1, x2 of 2 and x2 of 3. That is 4, 5, 6, 7. Okay. To get the x2 of 1 minus n, how to get x2 of 1 minus n from x2 of minus n means we have to rotate these values in the anti-clockwise direction by one sample. So here this 4 will come here, 4, and this 7 will come here, 7, and this 6 will come here, 6, and this 5 will come here. So we are rotating the x2 of minus n by one sample in anti-clockwise direction. Then we are getting x2 of this x2 of 1 minus n, we can write as x2 of minus n plus 1. Okay. So how to get y of 1 value? So to get the y of 1 value, take two concentric circles. The outermost circle is for x1 of n. We should not change the values here. The starting index is from here and we have to plot the values in the anti-clockwise direction. Then for the inner circle, we have to rotate x2 of minus 1 by one sample. So there we are getting here 4, 7, 6. Because this x1 of n is multiplying with the x2 of 1 minus n. So multiply the corresponding amplitude values. So 5 into 0, 0. So 5 of 1 will become 0 into 5 plus 4 into 1 plus 1 into 4 plus 7 into 2. That is 2 into 7 plus 6 into 3. 3 into 6. So here we are going to get 0 plus 4 plus 14 plus 18. That is 36. So y of 1 value is 36. We have to repeat this method for y of 2 and y of 3 also. For m is equal to, in the formula if we substitute, y of 2 is equal to sigma n is equal to 0 to 3 x1 of n, x2 of m minus n. M is equal to 2 here. So x2 of 2 minus n. So we are multiplying this x1 of n series with the x2 of 2 minus n series. So we already know how to plot the x1 of n. We should not change that circle. Only x2 of 2 minus n we have to change. So here to get the x2 of 2 minus n, we have to shift the x2 of minus n by 2 samples in the anti-clockwise direction. So first we are taking x2 of minus n, 4 minus n. That's why we have to take in the clockwise direction. First we are plotting them, but we have to rotate that in the anti-clockwise direction. We have to rotate that in the anti-clockwise direction by 2 samples. So this 4 will come 1, 2. 2 samples. So 4 will come here and 7 will come here 1, 2 steps. So here 7 will come and 5. It should move for 2 points. So here 2 samples. So 6 will come here, 5 will come here. So this is x2 of minus n plus 2. So then how to find out the y of 2? Same procedure. We have to take the two concentric circle. We should not change the x1 of n. We should not change the sample values of x1 of n. It is starting from here only 0, 1, 2, 3. And only we have to rotate the inner circle by 2 samples in the anti-clockwise direction to get the x2 of 2 minus n. That is nothing x2 of, we can write this as minus n plus 2 also. Okay. So here after rotating we are getting 6, 5, 4, 7. The corresponding amplitudes will be multiplied here. 1 into 5, 5. 2 into 4, 8. And 3 into 7, 21. The corresponding amplitudes will be multiplied and these will be added to get the y of 1. So here y of 2. So phi of 2 is equal 6 into 0. This product plus 1 into 5 plus 2 into 4 plus 3 into 7, that is 0 plus 5 plus 8 plus 21, that is 34 value we are going to get. For m is equal 3, same, we have to substitute in the formula and expand that formula. Here we have to x1 of n series is multiplied with x2 of 3 minus n. That x2 of minus n should be rotated by 3 samples in the anti-clockwise direction here. So here this x2 of minus n plus 3, so this 4, actually we have 4 here for x2 of minus n. This will be shifted to the 3 points. So here it came. It should shifted by 3 samples in the anti-clockwise direction. So this 4 is coming. This is x1 of x2 of n 1 for 4. So for x2 of n minus n, we have to rotate by 3 samples in the anti-clockwise direction. Then we are going to get these samples. To get the y of 3 value, we should not change with the position of x1 of n, because x1 of n is common for all the samples. So we should not change that circle. Only we have to rotate the x2 of minus n by 3 samples in the anti-clockwise direction. Then we have to multiply these corresponding amplitude values. The products will be added to get the y of 3. So y of 3 is equal, the corresponding amplitude value is 0 into 7 plus 1 into 6 plus 2 into 5 plus 4 into 3. So this is 0 plus 6 plus 10 plus 12. We will get the 28. So the output value is 34, 36, 24, 28. Y of 0, y of 1, y of 2, y of 3. Here we have 4 samples, because the circular convolution length is equal to the maximum of L comma N. So this is the procedure to find out the concentric circle method, circular convolution using concentric circle method. So just I will tell the next problem, how to draw the circles and how to plot the sample values. See here, 2 sequences 1, 2, 1, 2 and 4, 3, 2, 1. So here the length of y of n should be 4, because it has the maximum of L comma M. So x1 of n length is L is 4 and x2 of n length is 4. So this we will get maximum of L comma M, that is 4. So in the output we should get the 4 samples. So for first the values for small m is equal 0, 1, 2, 3. So for m is equal 0, first make 2 samples, 2 circles and make the equidistant, because 4 points, 4 samples, we should draw 4 equal distance samples. Outer circle is for x1 of n and inner circle is for x2 of minus n. So for outer circle, we should plot the sample values in the anti-clock direction. So here I am starting here x1 of 0. So it is 1, 2, 1, 2. So anti-clockwise direction, the outermost circle is in the anti-clockwise direction. For inner circle, x2 of 0, we should plot them in the clockwise, same index. The starting index for the both sequences should be same. So here 4 clockwise direction, because x2 of minus n we are writing here. Clockwise direction and multiply the corresponding amplitudes. So here 4 into 1 plus 1 into 2 plus 1 into 2 plus 3 into 2. So here we are going to get the 4 plus 2 plus 2 plus 6, 14. And for m is equal 1, same, we should not change the position, sample values of x1 of n. 4 equal distance. Here x1 of 0, that is 1, 2, 1, 2. And for inner circle, whatever the x2 of minus n is there, we should rotate by 1 sample. So here the star 4, it is rotated by the anti-clockwise direction, x2 of minus 1. It is 4 is starting here. This will be started here. Okay. 4, 3, 2, 1. 4, 1, 2, 3. The corresponding amplitudes will be multiplied here. Y of 1 is equal 3 into 1, 3 plus 4 into 2, 8 plus 1 into 1, 1 plus 2 into 2, 4. So we are going to get here 16. Okay. And for m is equal to outermost circle should not change, and those will be plotted in the anti-clockwise direction. So starting from here 1, 2, 1, 2, and innermost circle we have to shift by 2 samples. The x2 of minus 7 will be shifted by 2 samples. Otherwise, the before circle, inner circle, that should shifted by 1 unit. So here it is starting from 4, 1, 2, 3. So the corresponding amplitudes will be multiplied here. So y of 2 is equal 2 plus 3 into 2, 6 plus 4 into 1, 4 plus 1 into 2. The amplitude, corresponding amplitudes will be multiplied here. 1 into 2, 2. So here we are going to get 14. For m is equal 3, outermost circle we should not change here. That is 1, 2, 1, 2. Innermost circle, the x2 of minus n should be shifted because x2, we have in the formula, if we substitute, we will get the x1 of n into x2 of 3 minus n. So x2 of minus n should be shifted by 3 samples here. So it will become here 4, 1, 2, 3. Okay. The corresponding amplitudes will be y of 3 is equal, multiplied 1 into 1, 1 plus here 2 into 2, 4 plus 3 into 1, 3 plus 4 into 2, 8. So here we are going to get 16. So here the y of n value we are going to get is 14, 16, 14, 16. So this is the method to find out the circular convolution using the concentric circle method. So here for the find the circular convolution of x1 of n and x2 of n using matrix method. They are given two sequences here 1, 2, 3 and 4, 5, 6, 7 by using the matrix method. First of all, we have to know to find out the circular convolution, the length of both the sequences should be the equal. Here in the x1 of n we have the L is equal 3. The number of samples are 3. Here in the x2 of n, the number of samples are 4. So the length of y of n will become the maximum of L comma m. That is maximum of 3 comma 4, that is 4. In the output we will get 4 samples. But here the length of the both sequences are not equal. So we should make them equal by 0 padding. So here I am adding 0 to the x1 of n, 4, 5, 6, 7. So here these two sequences we are going to get here. In the matrix method we have take any one sequence. Here we are making the x1 of n length is equal to the x2 of n by adding zeros, that is 0 padding. Okay, make any one sequence in the column of the matrix 1, 2, 3, 0 and rotate this last these samples by 1 sample. So 0 will move first, so here it will come 0 and next sample 1, 2, 3 and 3 will become the first sample and these will come down. So 0, 1, 2 and 2 will come here, this 3, 0, 1. And if we shift the last sample, again we will get the first column. So we should stop here and the rotation will be up to the length of the y of n. And here the 4, 5, 6, 7. So if we multiply these two samples, we will matrix multiplication. This is x1 of n, this is x2 of n, and we have to get the y of n here. So 4 plus 0 plus 3 into 6, 18 plus 14. Second sample is 8 plus 5 plus 0 plus 21. 12 plus 5 to the 10 plus 6 plus 0. 0 plus 15 plus 12 plus 7. So here we are going to get the values are 36, 34, 18 and this one 34. So this is the values for the output y of n using the matrix method. Another problem is in the linear convolution method. In the linear convolution method, we have three types: graphical method, tabular method, and matrix method. We will see problems on these three methods, and we will get the same answer. If we do any method, we will get the same answer in the linear convolution. So, but we have to remember some points for the linear convolution. Here the length, if the x of n length is L, the number of samples in the x of n is L and h of n is M, then the output sequence length should be equal to the L plus M minus 1 in linear convolution, whereas in circular convolution it is maximum of L comma n. So here this L is here 4 and h of n length is 4, then it will be 4 plus 4 minus 1, that is 7 samples we will get in the output. First point is one. In second step, we should find out the starting index of the y of n. How to find out the starting index of y of n? How to find out the starting index of y of n? So if we take the x of n series, the arrow mark indicates the 0th sample. So here this arrow mark indicates the 0th sample. So in the index here, this is minus 1, this is minus 2, 0. So the starting index for x of n is minus 2. I am taking that as minus 2 n1. And for h of n, we don't have any arrow mark. So the starting index I am taking it is 0. Okay, so that is n2 is 0. So for y of n, the starting index is n1 plus n2. That is minus 2, and ending index is sum of ending indexes of x of n and h of n. So here 0, 1, 2, 3, here minus 1, 0, 1. So that is y of n ending index is 1 plus 3, that is 4. So the y of n is starting index is minus 2 and it has 4. So totally it has 7 samples. Minus 2, minus 1, 0, 1, 2, 3, 4. So totally it has 7 samples. So this is the method. First step, we have two basic steps to find out the starting index and index of y of n and the length of the y of n in the linear convolution. And then we have to represent these both sequences x of n and h of n in the index k. So plot those sequences here with the index k, that is x of k and h of k. So it is starting from minus 2, minus 1, 0, 1. So the starting index is 0, 1, 2, minus 1, minus 2. So here it is the amplitudes are 2, 3, 2 and 2. So this is x of k, and same procedure we have to draw for k, h of k also with the index k, h of k. Here for 0 sample it is 1, and for 1, 2, 3. So 0, 1, 2, 3 index. For n is equal to 1, it is minus 2. Amplitude for n is equal to, it is 3. For n is equal to 3, it is minus 1. Okay. And fold this h of k to get the h of minus k. We have to fold this h of k to get the h of minus k. That is nothing but h of minus k is here. A 0 sample we will get the same value k. So 1, minus 1, minus 2, minus 3 and minus 4. The first sample value will come here, the minus 1 sample, that is minus 2, and second sample it is 3, and third sample it is minus 1. Okay. So here in the formula, y of n for linear convolution, the formula is k is equal minus infinity to infinity x of k into h of n minus k. So here the index is starting from minus 2. So substitute y of minus 2 here. So we will get sigma k is equal minus infinity to infinity x of k into h of minus 2 minus k. So we have to get the h of minus 2 minus k. We have already h of k. So how to get the h of minus 2 minus k means we have to shift the h of minus k samples to the right side by 2 samples. So here to plot that, see here it is starting from 0. So it is, should shift from to the right side. So if the index at n is equal 0, we are getting 1 for h of minus k. So here we have to get that for 2. It should shift to the right side. So here we will get 1, minus 2 and 3 and minus 1. So this is minus 2 sample, minus 3 sample, 4, minus 5 sample. This is h of minus 2 minus k. So here to get the y of minus 2 sample, we have to multiply by the x of k with the h of minus 2 minus k. So these two graphical representation of x of k and h of minus 2 minus k will be multiplied. The corresponding amplitudes of the indexes will be multiplied and then it will be added here. So here the common points for both the sequences is here. At n is equal minus 2 we have 1 and at n is equal minus 2 we have 2. So for y of minus 2 is equal, for minus 1 we have 0 for h of k and other samples for x of k are 0. So the common value we are going to get only at n is equal minus 2. So the amplitudes at n is equal minus 2 for both the sequences will be multiplied. So it will be 2. For y of minus 2 we are going to get 2. Okay. In the same procedure we have to shift all the sequences. We have to draw all the sequences of the graphical representation and we have to multiply it with the x of k. So for example, x of k is minus 1, minus 2, 0, 1. This is k, x of k. So it is 2, 3, 2 and 2. And for n is equal minus 2, we already know about that one. For n is equal, after minus 2 we will get the minus 1. So for n is equal minus 1, the formula is sigma k is equal minus infinity to infinity x of k into h of minus 1 minus k. So we have to shift the h of minus k sample to the right side by the 1 unit. So here first we have to draw the h of k here, h of minus k, h of minus k here. The 0th sample is 1 and minus 1 sample is minus 2. It is 3 and it is minus 1. 0, minus 1, minus 2, minus. This is h of minus k. We have to plot the h of minus 1 minus k. So here h of minus 1 minus k will be the whatever the samples of h of minus k will be shifted to the right side by 1 unit. Right side by 1 unit. Okay. So here I am going to get here h of minus 1 minus k by shifting the sample value. So the 0th sample will come here. 1. This is minus 2. 3. Minus 1, minus 2, minus 3. And at minus 4 we will give the minus 1. Okay. And for y of 0, sigma k is equal minus infinity to infinity x of k into h of minus k. For y of 1, we have to get the k is equal minus infinity to infinity x of k into h of 1 minus k. For y of 2, this is sigma k is equal minus infinity to infinity x of k, here h of n minus k. So n is 2, 2 minus k. For n is equal 3, sigma k is equal minus infinity to infinity x of k into h of 3 minus k. Last sample is y of 4 because the ending index of y of n is 4. So that is sigma k is equal minus infinity to infinity x of k into h of 4 minus k. So here to get the, we know x of k and h of minus k, h of minus 1 minus k. To get the h of 1 minus k, 1 minus k is minus k plus 1. So we have to shift the h of minus k to the left side. So here h of minus k sequence is this one. We have to shift that to the left side. So the zeroth sample will come here. 1, minus 2, 3, minus 1. So it is 0, 1, minus 2, minus 3. This is k, h of 1 minus k. To get the h of 2 minus k, again we have to shift the h of minus k to the left side by 2 samples. Otherwise, h of 1 minus k to the left side by 1 sample. So here, this we will get here 0, 1, 2, 0, 1, 2. So it will start 1, minus 2. This is 3 and minus 1. So here like that we have to draw all the sample values and we have to multiply the corresponding graphs. So to get the h of k into h of minus 1 minus k, we have to multiply these two graphs here. X of k and h of minus 1, the corresponding amplitudes will be multiplied for the corresponding indexes here. So here it is 0 sample is 2 and here we have 0. For minus 1 we have 1 and here we have 3. That's why it is for y of minus 1 we will get the 3 minus 4, that is minus 1, because it is 2 into 2 4. So 3 minus 4 we will get minus 1. For y of 0 we have to multiply it with x of k with the h of minus k, because h of k into h of minus k and the corresponding products will be added here. So x of k and x of the common value is here. For 0 sample it is 1 and minus 1 sample it is minus 2 and minus 2 sample it is 3. So these 3 we have common values here. So 0 sample 0 into 2 2 and for say minus 1 sample it is 3 into minus 2 minus 6 and for minus 2 sample 2 into minus 2 minus plus 6, here we will get the 2, and like that we have to multiply each and every graphical representation of h of 1 minus k with the x of k, we will get the y of 1, and h of minus 2 with the x of k, we will get y of 2, and h of 3 minus k. 3 minus k means we have to shift this one to the 1, 2, 3. So here it will start from 1, minus 2, 3, minus 1. This is h of 3 minus k. And h of 4 minus k is, shift this one, 4, minus 2, 3, minus 1. So 4, 3, 3, 2, 1, 0. So this is h of 4 minus k. To get the h of 4 minus k, we have to multiply it with the x of k. These two will be multiplied. To get the y of 3, these two graphs should be multiplied, and the corresponding values we will get is this. We will get 2, 5. This is minus 1. This is 4 and this is minus 2 we will get. So the final output for the y of n will be, final output is minus 1, 2, 5, minus 1, 4, 2. So this is the output of y of n. But we have to represent the index of y of n, because x of n is starting index is minus 2. So the n1 plus n2, the starting index is minus 2 for y of n and end index is 4. Already we know this one. So the 0th sample is 5. So we have to represent arrow mark with the 0th sample. This is y of n value after convolving the x of n and h of n using graphical method. So find the linear convolution and x of n and h of n using tabular method. Here two sequences given, same sequence. We have to represent in the tabular method. In the tabular method, same y of n, already same we find out this one. Y of n length is here the L plus m minus 1, that is 4 plus 4 minus 1. Length of the x of n, length of the y of n, the number of samples are 4, 4. So 4 plus 4 minus 1, 7. The starting index of y of n is the starting index of x of n plus starting index of the h of n. So that is minus 2 plus 0, that is minus 2. And to find out the tabular method, take any one sequence and write that in the row, any sequence we can write 2, 3, 2, 2 and 1, minus 2, 3, minus 1 and this is in the row I am taking x of n, in the column I am taking h of n. Just represent the sample values and multiply the corresponding sample values, and 1 into 2, 2, 1 into 3, 3, 2, 2 and minus 2 into 2, minus 4, minus 6, minus 4 and minus 4 and 3 into 2, 6, 9, 6, 6, minus 1 into 2, minus 2, minus 3, minus 2, minus 2. So we have to multiply the corresponding sample values and we have to add. How to add these values? See here, draw the diagonal lines like this. Draw the diagonal lines like this. Then y of n. Here the y of n will become here. The first sample is 2 in the first diagonal and second in diagonal we have minus 4 and 3. We should add these two values here. So minus 4 plus 3 and second is 6 minus 6 plus 2 and minus 2 plus 9 minus 4 plus 2. In the next diagonal we have samples minus 3, 6 minus 4. Add these sample values. Whatever the diagonal line we have the samples, we have to add those samples. We will get the value 2 minus 1, 2, 5 minus 1, 6 minus 4 minus 2. So this is another method to find out the linear convolution using the tabular method. It is the very easy method compared with the graphical method. Okay, here we have to represent index of the y of n. So here the starting index is minus 2. So this is minus 2 sample, minus 1 sample, 0 sample. Here the 0 sample we should make the arrow mark. This is the tabular method for the linear convolution. So here we have to take the any sequence. We can take the x of n in row wise, otherwise h of n also we can take in the row. Another sequence we should write in the column and multiply the corresponding sample values and make the diagonal lines and add the values of the particular diagonal column. So another method for the linear convolution is matrix method here. In the matrix method, so here we have x of n length is 4 and y of n length is, h of n length is 4 and y of length is L plus, this is L, this is M, L plus M minus 1, that is 4 plus 4 minus 1. So to get the L plus M minus 1 here, we have to add any sequence length should be equal to the length of the y of n. How to add make the length of the x of n is equal to the y of n means we have to add zeros. So 2, 0, 2, 2, 0, 0, 0. 7 samples we are getting here. 7 samples. So h of n is 1 minus 2, 3 minus 1. So the same matrix method as for circular convolution, same we have to take any sequence. So here I am taking 2, 3, 2, 2, 0, 0, 0. Rotate this last sample to the first 0 and these samples will come down 2, 3, 2, 2, 0, 0 and 0, 0, 2, 3, 2, 2, 0 and 0, 0, 0, 2, 3, 2, 2. So here we have to rotate these samples to the length is equal to the h of n and multiply with the, because 7 by 4, the order of the matrix is 7 by 4. H of n is right in the column matrix 1 minus 2, 3 minus 1. This is 4 by 1. So we will get the y of n is 2. Here same we will get the, by adding this one, same values we will get to like minus 2, minus 1, 2, 5, minus 1, 4, minus 2. So this is y of n value. Before already we got these same values, same question. So answer will be same for the any 3 methods. If you do any 3 methods in the graphical method, concentric circle method or matrix method, we will get the answer will be the same. And how to find out the linear convolution from the circular convolution. So here in the linear convolution length, for linear convolution, the length of y of n should be equal to the L plus m minus 1. Okay, but we have here 4 samples. So in the using circular convolution, what we have to do means we have to make the both length should be equal to the 7. Length of the y of n, that is 4 plus 4 minus 1 is equal to 7. So 2, 5, 0, 4, 0, 0, 0, 7 samples. By adding zeros, we are going to get the x of n value, and h of n also 4, 1, 3, 0, 0. Here we have to add 4 samples to make the length equal to the y of n. So 0 padding. Then take the sequences 2, 5, 0, 4, 0, 0, 0, and rotate this one 0, 2, 5, 0, 4, 0, 0, again 0, 0, 2, rotate. This last sample will come to the first and these sample will come down. So 0, 2, 5, 0, 4, 0, again last sample will come to the first, 2, 5, 0, 4. This we should repeat for up to the length of the y of n. 7 times we have to do. So 4, 0, 0, 0, 2, 5, 0, and this last sample will come to the first. So 0, 4, 0, 0, 0, 2, 5, and 5 will come here, 5, 0, 4, 0, 0, 0, 2, and if we repeat again this rotation, we will get the first column. So stop it here. So 7 times the length of the y of n is 7. So 7 times we repeated this one. So the last sample will come to the first. So 0 will come here. These will come down. Okay. And this will be multiplied with the sample 1, 4, 1, 3. Write in the column matrix h of n and multiply the corresponding values here. So 8 plus these are 0, 0 plus 0 into 3, 0, 0. So 4 into 0, 0, 0. So in first column we will get 8. In second 5 into 4, 20 plus 1 into 2. 2 plus 0, 0, 0. All will be zeros. And in third column 0, 5 plus 6. In fourth column we will get 16 plus 15. All zeros. And in fifth column 0 plus 4, 4. So 4 only, 4 plus zeros. And in third column 4 into 3, 12. And last column we will get the 0. So the final output is here 8, 22, 11, 31, 4, 12, 0. So the length of the y of n is equal to here 8, 22, 11, 31, 4, 12, 0. So the starting indexes both are 0. So y for y are n. So here in the linear convolution, the length is equal to the L plus m minus 1. So 7 samples we are getting. For the circular convolution, it is maximum of L comma 4. That is, we will get maximum of 4 comma 3, 4 samples. But here we have to find the linear convolution using circular convolution. So find the linear convolution using circular convolution, we should make both the sequence length should be equal to the L plus m minus 1. Okay. So these are the problems discussed here about the linear and circular convolution. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.